Perfect gas has a molar mass of 26 kg per kmol and value of gamma is 1.26. Calculate the heat rejected in the following cases. When unit mass of the gas is contained in a rigid vessels at 3 bar and temperature is 315 centigrade and is then cooled until the pressure falls to 1.5 bar. Unit mass flow rate of the gas enters pipeline at 280 centigrade and flows steadily to the end of the pipe where the temperature is 20 centigrade. Neglect change in velocity of the gas in the pipeline. So in the pipeline there is a perfect gas flowing. We need to find the heat that is rejected from this pipe. This is, let's say, a pipe of any diameters that is not specified, in which perfect gas is entering and then leaving from this pipe. Due to this flow of perfect gas in the pipe, a change in its temperature occurs. While during its change in temperature, the corresponding heat rejections or heat loss from this pipe occurs. We need to calculate that heat loss and heat that is rejected from this pipe, and that is Q R rejected heat. Okay, let's come to its solution. Molar mass is given 26 kilomole. Gamma value is 1.26. We need to calculate the heat rejections. In first case, and there is a unit mass and the vessel is in the rigid space. So in first case there is a volume of vessel that is fixed, whose pressure is reduced from 3 bar to 1.5 bar, and correspondingly its temperatures are also dropped. Then we need to find the heat rejections that is taken place from these vessels. This is for case 1 and this is for case 2. I hope you understand. If still in confusion, you can ask in the comment section. Pressure 1 is, let's say, 3 bar. The pressure P2 the final temperature is not given. Conditions, what it says, so mass flow rate is 1 kg per second. Temperature T1 at the inlet of the pipe, that is T1, at the outlet of the pipe, that is T2. T1 temperature is 280 centigrade and temperature is T2 at the exit of the pipe, that is 20 centigrade. Change in velocity is almost negligible, it means to say 0. In the first case and in this second case, we need to calculate the heat rejections that occurs while the gas is in the vessels, while gas is flowing in the pipe. So let's come to its solution. The gas constant value is equal to universal gas constant divided by its molar mass. Molar mass is given, that is 26. Universal gas constant value is constant, it is 8314.5 divided by 26. You will get that value, that is divide with 1000 to convert into kilo. So gamma minus 1 into CV is equal to gas constant R. We are interested to find the CV value. Divide both sides with gamma minus 1. Gamma minus 1, it will be cancelled out. So by rearranging, CV is equal to R divided by gamma minus 1. Now gas constant value is 0.3198 divide gamma value, that is given 1.26. After solving, you will get the CV value, that will be equal to 1.229. Also we know gamma is equal to Cp by Cv. Then Cp is equal to gamma times Cv it is gamma. It is given 1.26 and CV value is 1.229. So after simplifications, you will get the CP value is 1.548. The heat rejection in the first case, it says the volume of the vessel is rigid, so it means that volume V1 and V2 is fixed and it is same. You also know that P1 V1 is equal to RT1, also P2 V2 both side is R, so equation 1 and 2 must be same and equal. So I can say that P1 V1 divided by T1 is equal to P2 V2 divided by T2. Since it said in the statement that V1 is equal to V2, will be cancelled out. We are interested first to find the T2 in order to find the heat rejections. So T2 is equal to P2 value is in the first case is 1.5 divided by T1 value is 3. Then T1 value is in the centigrade, that is 315 centigrade. Convert that into Kelvin, add 273 with it, it will become equal to 588 Kelvin. So they write one values here, that is 588. After solving this, you will get the T2 value, and it is next is to find the heat rejection that is taken place in the first case. It is equal to CV, change in temperatures, and change in temperature is equal to T2 minus T1. And what is CV value? It is determined here, you can see it is 1.229. T2, that is 294 minus 588. After solving this, you will get Q value, and it is minus 361. Remember, this negative sign means that heat rejection. Now we will find the heat rejection in the second case when there is a pipe and perfect gas is flowing in it. So here is the condition 1, here is the condition 2. I apply the steady flow energy equations. Input, so it will be 0, it will also be equal to 0. It means that mass flow rate into H1 plus Q dot is equal to M dot H. Further, I can say that Q dot is equal to M dot H2 minus H1, and this is called change in enthalpy, and it is equal to M dot change in enthalpy, and this change in enthalpy is further equal to Cp into change in temperatures is equal to T2 minus T1. Now put the values in these equations. You will get the heat rejections taken place from this. So in the second condition, it says the mass flow rate is taken 1. So in the second condition, it says mass flow rate is taken 1. Cp value is 1.548. T2 is 20 minus T1 is 280 in the second condition. After solving that, you will get the heat. After solving this, the heat rejections through the gas pipeline will be minus 403 kilowatt. And this is our final answer. Negative sign means that heat rejection is taken place from the gas pipeline. I hope you understand. If you still in confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed yet. Thank you so much.